If you have any questions, just like chime in at any time and be like, yo, how do I do this? Blah, blah, blah. So I've started the recording there. I've got my calculator open in the background because I'll see if I can do the exam 2 and the exam 1 in the same sitting. But here we have exam 1 for methods. I'm just going to start reading through it. So here, first question, basic, differentiation question, what you should expect. Next one is an antiderivative question, antiderivative. Yep, so 3 antiderivative questions back to back, so nothing too crazy. This one here, it looks harder than it is, but we'll make sure we'll discuss this one a little bit more. And then it says solve this equation. It doesn't look too bad. Here, what we have is we have to sketch this function over this domain. I'm just going to be mindful of the domain. It doesn't go on infinitely. And then it says here, the average rate of change. That's not too bad. Okay. Here we have a probability. Find the value of p. That shouldn't be too bad. E of x and the variance. Again, it's pretty straightforward calculations. A passenger catches a train at the train station on 5 different occasions. What is the probability that that the train arrives before the scheduled time on exactly 4 of these occasions? We'll discuss this one. Here, this is sampling, and like this is the general sampling question that you'll see, Mia. We haven't talked about sampling, but you'll see how straightforward sampling is. Yeah. If we keep going down, right, we have here find f of x. F of x is in the form, f of g of x is in this form, and wants me to transform f of x onto f of g of x, and wants me to find the value of a, b, and c. Here, it says you find the domain and range of the inverse function, solve for f of x equals f inverse of x. That's not too bad. This looks very cooked. Find the value of c for which g of x and f of x g of x equals f inverse of x has no solutions, and for what values of c does g of x, g dash of x have exactly one solution. So let's try and smash through this one as quickly as possible. It's 106 right now. I'm going to see if I can do this as fast as possible. So here, 2 marks. That means I need working out plus an answer mark. So here, I'm just going to put my, this is a basic chain rule one. So here we have a cos of x over 2. B dash is a half neg sine of x over 2. Here, dy on dx must just then be minus e to the 2x sine of x over 2 plus 2e to the 2x cos of x over 2. Here, this question, it's 2 marks, so I only want 2 bits of working out. So here, f dash of x, the derivative of a log is just 1 over that whatever's on the inside. So here it's 1 over sine times by the derivative of sine, which is just cos. Here I can then just substitute an f dash of pi over 3, and here we do 1 over root 3 over 2, because that's sine of pi over 3, times it by a half, which is just 1 on root 3 is my answer. Yeah. So here it asks us to find an antiderivative. When it says an antiderivative, we don't need plus c at the end. So here we just want to find the integral of cos of 1 take away x dx. That is just going to be equal to negative, negative sine of 1 take away x. Here you can put the plus c. You can also, you don't need the plus c, but you can put it. That's what an antiderivative means. It just wants a antiderivative. In fact, you could put plus 5 or plus 15 or anything. It doesn't really matter. Here, so this is where like the exam writing is coming in. Here it says evaluate this integral. So here, if I want to evaluate this integral, I want to first make every power positive. So here we have here 4x to the power of 2 dx. This is negative. And here we're just left with x cubed take 4x to the negative 1 here from 1 to 2. Here this is going to be 8 take away 2 take 1 take away 4, right? So I'm just doing that f of 2 take f of 1 in my head. And then here I get 6 take away neg 3, which is 9. So here, yeah, and here, yeah, okay. Here it says f of x is this, f of 4 equals 25, f dash of x is this. So here where x is greater than 0. So here we want to try and find out the rule of f of x, which is just going to be the integral of 3x squared over 8 take 10x to the negative a half plus 1 dx. And that's going to be equal to, here it's going to be x to the power of 3 over 8 take the 20x to the power of a half, because you times it by, you divide it by a half, which means you times it by 2 plus x plus c. Here f of 4 equals 25. So here we have 25 equals 64 over 8 take 40 plus 4 plus c. Here this is just 8 take away 40 plus 4 plus c. What we're left with is just neg 32 neg 28 plus c, which means that c equals 53. Here I'm just going to check that working out really quickly. Yeah, it looks about right. So here that means f of x is just going to be equal to x cubed over 8 take 20x to the half plus x plus 53. Does that make sense, Mia?
Yeah.
Okay. So here we want to find out the smallest value of k for which x equals 3 pi over 4 is a solution for this. So here that means 10 of 3 pi over 4 is equal to cos of 3 pi k over 4, right? 10 of 3 pi over 4 is just going to be negative 1 cos of 3 pi k over 4. So here we're just letting cos equal 3 pi k over 4, right? Here that means that 3 pi k over 4 is equal to, here it could be 3 pi over 2, right? Because here we're looking down here. That means I think one of them joined the wrong link.
What?
I think one of them joined the wrong link. That's kind of embarrassing. Very tough. That's actually very tough. Holy shit. Right, this guy. At least I might have 2 people now. Where the fuck my mouse at? Okay. So here that means that 3 pi k is equal to 6 pi, and hence k is just equal to 2. Let me just get. Hey Joe, I've already started with some of the questions. So it's been about 6 minutes, and I finished 4, 9, 10 marks already. Here we have 2 sine squared x plus 3x take away 2 equals 0. Right? We can let u equal sine of x because this is just a hidden quadratic. So that means 2u squared plus 3u take away 2 equals 0. Hence, we'll have here 2u squared plus 4u take 2 equals 0. Hence, we have 2u u plus 2 take 1 u take plus 2 is equal to 0. Hence 2u take away 1 u plus 2 equals 0. Hence we'll have a u either equals a half or negative 2. So that means sine of x is just equal to a half, because sine of x cannot be equal to 2. Cannot be equal to negative 2. It's not possible. Yeah. So then if I bring the working out up here, I get sine of x equals a half. That means x is just going to be equal to, we're looking in these 2 quadrants here, x is just going to be equal to pi over 6, comma 5 pi over 6. Here we have this one. It says here, sketch the, so So sketch the function where f of x plus 1, find the points, label the asymptote. I'm going to come back to this one a little bit later, because sketching always takes me a little bit of time. Here it says find the average rate of change of x equals negative pi over 8 plus x equals pi over 8. So we need to remember that the AROC formula, right? Oh, wait. Here it says average value. I almost dropped the mark there. So it says average value, not average rate of change. So that means that a average is just equal to 1 over pi over 8 take neg pi over 8, right? From pi over 8 to neg pi over 8. Here, this will be use the feature of the graph to determine the average value. So here, okay, actually can't do this one without the second part. So I'll come back to these ones, because sketching always takes me a little bit of time. So I'm gonna do it at the end, because I don't really like sketching. Here it says records of the arrival times of the buses. This represents minutes after, right? After the the random variable x represents the number of minutes after the scheduled time that the train arrives at the station. So here, this means that it arrives on time. This means it arrives 1 minute late. This means it arrives 2 minutes late. That's what this means. This means it arrives 1 minute early. Yeah? And so here's our probability distribution. To find out the value of p, we know that the sum of the probabilities must add up to 1. So here, if I add up the probabilities, they must add up to 1. So that means p is just going to be 0.2 here. Here, so I'm going to put 0.2 into this little box. It wants me to find out e of x now. Remember, e of x is just me multiplying these two together and then adding everything up. So it's negative 1 times 0.1 plus 0 times 0.4 plus plus 1 times 0.3 plus 2 times 0.2, which is just going to be neg 0.1 plus 0.3 plus 0.4, which is just going to be 0.6. My answer there. And here it wants me to find the variance. So the variance of x is just equal to e of x squared, take away e of x all squared. Here, if I square this, I get 1, 0, 1, and 2. That's what x squared is going to be. So here, e of x squared is just 0.1 times by 1. So here, it's 0.1 times by 1, plus 0 times by 0.4, yeah? Plus 1 times by 0.3, plus 4 times 0.2, which if we add all those up together, we get 0.1 plus 0.3 plus 0.8, which is just going to be 1.2. So here, that means the variance of x is just going to be 1.2, take away 0.36, because that's what 0.6 squared is going to be. So we get here 0.84 as my answer, the variance. Here, a person catches a train at the bus on 5 separate occasions, so 5 separate occasions. It says here, what is the probability that the train arrives before schedule exactly 4 of these times? So it arrives before schedule, yeah? For it to arrive before schedule, it has to be early. So that means here, the probability of it arriving early is 0.1, yeah? However, this is on 5 separate occasions. So this means n is 5. This actually tells us it's a binomial distribution. So here, the probability of x is equal to 4, right? Which is equal to 5 choose 4 times by 0.1 to the power of 4, 0.9 to the power of 1. Here, 5 choose 4, if it's in the form n choose n take away 1, the answer is always just going to be n. So here, this is 5 choose 4. So that means the answer is 5 times it by, here it's going to be 1 over 10,000, so 10,000 times 9 over 10, which is just going to be 45 over 1, 2, 3, 4, 5, which is just going to be 0. Here 1, 2, 3, 4, 5, so 0, 0, 0, 4, 5. That's the probability that it arrives before schedule exactly 4 of these times. Yeah. Now here you can keep the answer as the fraction. You can actually simplify this fraction if you want to. Yeah. Or you can write it in decimal point. I'm going to write it as a fraction just because that's how they would more or less expect you to write it. So here this would be the same as 9 over 1, 2, 4. So it'd be 9 over 20,000. Here, right, it says at the sporting outlet, there's employees, 5 men, 4 women. 4 of the people are rostered, right? So this is the number of people that I'm picking. Yeah, and P hat represents the proportion of people who are men. So here, this is actually a new unit for the two of you. You won't have seen this, but this will be the majority of the sampling questions. Yeah? So here, I'm picking 4 people, and I want to find the proportion, like, the P hat represents the sample proportion that are men. So here, the possible values of P hat, well, the thing is, we can either pick out 0 men, 1 man, 2 men, 3 men, or 4 men. Yeah? So here, if we pick out 0 men, the proportion of men that I picked out is 0 over 4. If I pick out 1 man, it's 1 over 4. If I pick out 2, it's 2 over 4. 3 over 4. 4 over 4. Which we can simplify some of these expressions into 0, a half, and 1. Now here, if I pick a proportion, a sample proportion of 0, if I look at my methods formula sheet, I know that P hat is equal to x over n. I can only find probabilities in terms of x. So here I need to do x equals n times P hat here. So here I know that n equals 4, P hat is equal to 0. So that means the probability of x equaling 0, x is going to be just 0. Yeah, that's these two are equivalent statements to each other. Now what I do is I want them all to be women, basically. So here,
Wait, why is P hat equals 0?
because the question says P hat equals 0.
Oh, whoops.
That makes sense?
Yeah.
So these are my possible values of P hat, and they've just selected one. So here, we can have, right? So here we want them all to be women. So we can either have 4 over 9 times 3 over 8 times 2 over 7 times 1 over 6. Yeah? Because here, this is the probability that this is a woman. I've chosen a woman again. I've chosen a woman again. I've chosen a woman again. So here, this can simplify down to, so the 8 at the bottom cancels out with the 4 and the 2. The 9 at the bottom cancels with the 3 and leaves us with just 3. So now we're just left with 1 over 3 times 42, which is 1 over 126. Here, there are 80,000 spectators. 5 in 9 of these spectators support this team. A random sample of 2,000 is selected. What is the standard deviation of the distribution of people who support this team? Yeah. So here, if I want to find the standard deviation, I use the standard deviation formula. So I know that a sample proportion of these is going to be 5 out of 9, or the population proportion is going to be 5 out of 9. So that's what P is going to be in this case. Yeah? So population proportion is the whole stadium. Yeah? It's if I pick these 80,000 people. Yeah? But now they're picking 2,000 spectators. So here, the standard deviation of P hat is just going to be 5 over 9 times 4 over 9, because it is P times by 1 take away P, divided by 2,000. Yeah? Here, we can simplify this expression like this. So here, we're left with 20 over 9 times 9 times 2,000. Yeah? 20 over 2,000 just becomes 1 over 100. Yeah? So now we have here 1 over 9 squared times 10 squared, which means our answer is just going to be 1 over 90. Here it's asking me to find g of x and f of x, right? So here g of so here this is g of 2x cubed plus 1, which is just going to be 4 take 2x cubed plus plus 1, which is just going to be minus 6x cubed plus 2, yeah? So it's going to be minus 6x cubed plus 2. Wait, no, not minus 6, this is minus 4, my bad, minus 4. So minus x cubed plus 2. Here it says here, find what f of g of x and express it in this form, right? So here, f of 4 take away 2x is equal to 4 take away 2x cubed plus 1, yeah? Yep. So then what I can do here is I can actually do 2, and I'm going to put outside the brackets of these two. I'm going to have here x cubed take 2. And all of this thing is going to look something like... Wait, I've stopped this, that's why. I've written this one. This is what happens when you try and rush. Make mistakes. So it's 4 take away 2. The cube is on the outside, plus 1. So here, what I can do is I can factorize out the 2. So I get here, x take away 2 cubed plus 1. Here, what I can do is I can do 2 times by neg 2 to the power of 3, brackets x take away 2 to the power of 3 plus 1. So here what I'm left with is neg 16 x take away 2 to the power of 3 plus 1. So if I get in the form, it's 1 take away 16 x take away 2 cubed. That's the answer I'm going to be left with. So then it says here, the transformations of the following were A, B, and C. So basically, what this translates to is it wants me to find x comma y, right? When that becomes x plus b, so I read the top, comma ay plus c when I read the bottom, yeah? And here I want to transform g of f of x into f of g of x. So I want to turn this function into this function. So here, let's first look at it. Well, so here first I have to do a dilation in the horizontal axis. So here, right, I need to do a dilation because here we have 4, here we have 16. I have to do a dilation by a factor of 4 from the x-axis, yeah? So dilation by a factor of 4 from the x-axis, because that will turn minus 4x, let me write it down here, minus 4x cubed plus 2 into minus 16x cubed plus 8, yeah? So now I need to work on the translations, yeah? So I have to translate this one, translation by 2 units to the right, which turns this function down here into minus 16x take away 2 cubed plus 8. And then I need to do a translation of by 7 units down to turn this function into negative 16x take away 2 cubed plus 1. Yeah? So that means here that a equals 4, b equals 2, c equals negative 7. Yeah? Negative 7. If I keep going, here it wants me to find the inverse function and the domain and the rule of the inverse. So here f inverse of x implies that x equals f of y, right? Which means x equals the square root of 2y plus 3. Take away 1. So if I rearrange this, I get x plus 1 over 2, take 3 squared over 2 equals y. Hence, f inverse of x is equal to x plus 1 squared take away 3 over 2. X take 1 squared, take away 3 over 2. And here, the domain of this function, if I sketch this one, it's going to look something like this, where it starts at negative 3 over 2, comma, negative 1. The domain of this one is going to be negative 1 to infinity, because the range of the original is the domain of the inverse, yeah? here, if I want to solve this equation, what I can simply do is I can do f of x equals x, yeah, because they have to intercept on the line y equals x. So what I can do is I can do here the square root of 2x plus 3 plus 1 equals x, which means here the square root of 2x plus 3 equals x take away 1. I can square both sides, so I get 2x plus 3 equals x take away 1 squared. So here we get x squared take 2x take plus 1, which means that 0 which equals 2x plus 3. And here that means 0 equals 2x squared, take away 4x, take 2, which will mean that here we can use the quadratic formula. So it'd be 4 plus or minus the square root of 16 minus 4ac. So here 4ac is going to be plus 8 over 2a. So a is just 1. So what I'm left with is 2 plus or minus the square root of 24 over 2, which will become 2 plus or minus the square root of 6, because I can take out a 4 here and it becomes this. Yeah. Now the issue with 2 plus or minus the, is there an issue? The issue with 2 plus or minus the square root of 6 is it's outside the domain of this function. So that means hence x must be equal to 2 plus the square root of 6, because plus or minus, right, it will go outside the domain of f inverse of x, and they won't intersect each other. So that means here x is equal to this. I'm just going to check over that working out really quickly. Here, yeah, everything looks fine. Okay. Now we have this question. This question it looks kind of cool. It says here, so this is g of x, where g of x, where c is a real number. For what values of c does g of x equal g inverse of x have no solutions? So when it has no solutions, the two graphs are going to look something like this. Yeah, that's when they're going to have no solutions. And here, the last time that they have no solutions is when they intercept this line. Yeah. So they intercept the line y equals x. So what I can do is, the last time they're going to intersect each other is when both graphs look something like this. Yeah. And do you see that y equals x is a tangent of both of these graphs? So I'm going to use the fact that y is a tangent to develop these two equations. I can develop the equation that g of x must be equal to x because it must intercept the line y equals x. But I also know that g dash of x must be equal to 1 because the gradient of the tangent at the point of x is going to be 1 because that's the gradient of x. Yeah, so here what I'll have is x. So here I have is x equals the square root of 2x plus c, take away 1. And over here, I have 1 equals 1 over 2x plus c. Here, that means that 1 equals 2x plus c, which I can actually substitute into my top equation. I know that x equals 1 take away 1, which means x equals 0. So I have a 1 equals the square root of 0 plus c, which means that c has to be equal to 1. Yeah? That's when this is when it has one solution. Yeah? However, right, what we need to think about is this c is going to be translating it to the left. Yeah? The more and more it pushes it to the left, right, or the bigger the value of c, the more it pushes it to the left. So here, c is actually just going to be greater than 1. If c is greater than 1, it's going to push it so far to the left that neither of them actually intersect each way. Wait, let me think about this one. C equals 1. Okay. No. C is... So, I mean push it forward. So, C actually has to be less than 1. So this is the diagram that I have, yeah? Do you see, right? If I push this one to the left, yeah, it's gonna like the two graphs are gonna look something like this, yeah, where they're gonna intersect each other twice. But if I push it far enough to the right, these graphs will be in separate areas. This is the reason being is because of this transformation, right? This transformation, right? This C transformation will push the inverse up and will push g of x to the right. So this transformation will push. How do I explain this? So if C increases, this function g of x will go to the right. No, sorry, it will go to the left, right? Because we don't trust our x. Which means if I push it, if I keep pushing it to the right, it's still going to intercept this line y equals x. But if I push it to the right, yeah, it's not going to intersect. It's going to be over here, right? That's way further away than it is from this line y equals x. So that's why C is less than 1 here. I would recommend you go back and do this question yourself and think through the logic and think through the intuition behind it. The next part here, it says here, for what values of C does g of x have one solution? So here we'll actually come to a case where both the inverse functions, their tips are touching each other. And then after that, right, the graph will be over here, one of the graphs will be down here. It's going to be like this, where it has one intersection. Yeah. So I want to find this point where the turning points of those graphs intersect each other. So the turning point of this graph is negative c over 2, and this is negative 1. Yeah. That means negative c over 2 must be equal to negative 1 because it intercepts at the line y equals x, which means negative 1 must be equal to negative c over 2, which means that c has to be equal to 2, yeah? Which means if c is greater than 2, we're going to have exactly one solution. But c can also be equal to 1 because when c is equal to 1, then it's going to be tangential, yeah? So these are our two solutions here. So if I go back up here, I'm just going to do this. I'm just going to do this question here. So it gives me this domain. Here I want to go from tan of here. It's going to have an asymptote at pi over 4. So it's going to have an asymptote here and here. It's going to intersect at this point, and this point. So here I'm just using, so I'm doing a quicker version of my of the tan graph rule that I showed you. Yeah. But here, what should happen is that it actually intersects over here. So it intersects, it goes down. Let me just try and sketch this one right. Goes down and goes all the way down. This point here is going to be negative pi over 8, comma 0. Over here, this graph, one period apart, is going to have an intersect of, here, this one is going to be pi over 8. So this part's going to go up. This part here is going to go up. So here, so this point here is going to be a period apart. So it's going to be 3 pi over 8, comma 0. And here this point is 0, comma 1. This point is negative pi over 2, comma 1. And this point here is pi over 2 comma 1. So here, let me just check if I put everything there. Yeah, I put axes, intercepts, asymptotes where appropriate. So here it says here, use the features in part A to find the average value. So here, I can't integrate tan. That was my issue with doing this question before. But I still want to find the average value of this. I need to find this area in some way, because here my average value formula is b take away a from a to b f of x dx. Do you see how this area actually nicely fits in over here and gives us a height of 2? So a rectangle with a height of 2 and a area of pi and a length of pi over 8. So here, the y average is just going to be equal to 1 over pi over 8 take negative pi over 8 times by the area, which is just 2 times pi over 8. Yeah? Here we get 4 over pi times by 2 times by pi over 8, which will just leave us with an average value of 1 here. Does that make sense? It's a bit weird, right, for me to do this, but this is what they wanted me to do in this case. So I finished that exam in about 34 minutes. So if I had more time, I would go back through and I'd reread all the questions and I'd see, if I'd made any mistakes. But here I'm going to jump over to the exam 2 and start working through this one. Yeah. So here I have my calculator with me. I'm going to have a little look through. I'm going to skip the multi-choice for the time being. I'll come back to the multi-choice. Yeah. Let's look at the extended response. So I'm going to use the black pen. And here my calculator screen is free. Here I'm going to define the function. So here the function is going to be t of t. I'm just going to define it as t of x because my calculator doesn't like t of t. Yeah. 19 plus 6 sine of, here we have pi over 12. Here this becomes x take away 8. Yeah? So I've defined that function there. So here it says the temperature of the office on this time. Yeah? So it's just the temperature of the office. The maximum of this one is just going to be 13 degree, is going to be 25 degrees Celsius. And the minimum of this one is just going to be 13 degrees Celsius. Here, the temperature at 6 a.m. This starts at midnight. So that means this is going to be at t of 6. So I do t of 6. Here, if I plug it in my calculator, t of 6, I'll get 16. Yeah? So here, 16 degrees Celsius. Right? Most of the people working at the office arrive at about 8 a.m. What is the temperature of the office when they arrive? So this is just going to be t of 8. So here, t of 8 is just 19 degrees Celsius. So here I get 19 degrees Celsius. Here, just going to check something. I'm going to check that I've properly defined this one. Yeah. Here it says how many hours of the day is the temperature greater than or equal to 19. So one thing that I wanted you guys to notice from that trial exam is with a lot of questions, you want to actually sketch them out. So here, this is going to be, I'm going to plot these two parts here. And here it says how many hours will it be greater than or equal to, it will be greater than or equal to 19. So here I'm going to look at I'm going to change the graph, right? So here I'm going to do zoom, settings. Here I'm going to go all the way from -1 to 25. The reason I'm going from -1 to 25 instead of 0 to 24 is because I want to have that whole function. I want to be able to see the whole thing. And then here I want it to go from, let's just say 12 to 26. It just gives me a little bit of leeway. So this is what the function should look like. And here I want to find out these 2 points, and I just want this section above here. So this section, this upper section. So here what I can do is I can do 3, 1. And I can do t of x equals 19, comma, x, where here x is between these 2 values. So here x is between these 2 values. So I get x equals 8, x equals 24. So here, if I wanted to try out a working mark, I'd do here t of t equals 19. Hence t equals, here if I look at my calculator, it's 8 and 20 and 20, right? Which means that the time difference between them is just going to be, it's going to be for 12 hours. Yeah, that's all you need to put down here. What is the average rate of change of the room from 8 to noon? So noon is 12 p.m. So here I want to find the average rate of change, which is just going to be f of 12 or t of 12 take away t of 8 over 12 take away 8. If I put that into my calculator, here, put that in my calculator, I get f of 12. Oh wait, not f, sorry. T of 12, take t of 8 over 4. I'll get here 3 root 3 over 4. So here, 3 root 3 over 4. The next part of the question asks me for the derivative of the function, which is very easy. Just do menu for, do here, menu for 1, t of, wait, x, t of x. Here, I'm going to write that whole function down. So I have that on my second monitor right now. So I have a negative pi all over 2 cos of pi x over 12 plus pi over 3. Yeah? I'm going to bring this one back over here. And then it says here, at what time is the office's temperature most rapidly decreasing? Now, to highlight this to you, I'm going to, again, sketch the graph. Yeah? So here, control doc 2. Here, I'm going to sketch this graph here. So here, I'm going to do control C. I'm going to go over here, right here. I do control V. I sketch this graph. And I'm going to change it to... I'm not going to change the height. I'm just going to change the zoom. So here, I'm going to go from -1 to 25. So here, I go to, let's just say -3 to 3. Just picking some values out. And here, one thing that I want you to notice is at the turning point here, so when it hits its median line, that's when it's going to change the fastest. So here, the median line of this function is 0. And do you see how it's changing the fastest at 0? This is a very important trig identity, because a lot of trigonometry, you don't want to try and deal with it like using the traditional methods, like to find maximums using calculus, because it takes a long time. Yeah. So instead, I'm looking at the function. I'm seeing here that, okay, let me just not change it. I can see here that when it hits the median line, it's going to experience a turning point. So here, if I go menu 5.1, if I do my sketch here, I can see it hits that median line at 14. And because we care about when it's most rapidly decreasing, this is when it's decreasing. Yeah. So here, it's just going to be, for the sake of working out, I'm going to just put t dash of t equals 0. Hence, t equals, here I would have multiple values, right? So here I would have here, sorry, it says most rapidly decreasing. I'm actually stupid. Give me a second. Let me just reevaluate that one. When it's most rapidly decreasing, it's going to be either at a maximum point or a minimum point, because we care about when it's most rapidly decreasing, we care about this minimum point here. So here, what I'm going to do is I'm going to say that t dash of t equals negative pi over 2. That's its amplitude, that's its minimum point. And here, by looking at the graph, we know that t equals 20. Was there something you wanted to say, Mia?
Yeah, so was everything you said about the median
No. So that was true. It's just that I was referring to the wrong function. If I looked at this original function, right? So here, I know that 19 is the median line, yeah? 8 is going to be the point where it most rapidly increases, yeah? And if I go to the point 20, do you see that's where it most rapidly decreases? This is the original function, yeah?
Okay.
Does that make sense?
Wait, so it most rapidly decreases at the median line?
Yeah, it most rapidly decreases at the median line.
All right.
Make sense? Okay. Sure. So I have the next question over here. I'm gonna say this now. This is a very easy first question, right? This second question, and are you seeing that these questions are a little bit more straightforward than the exam that you guys were given? Like, there's no riddles, there's none of this other bullshit. This is more of what the VCAR exam is gonna look like. So here I'm gonna do doc41 to pull up a new page, and I'm gonna define the new function. So here I have f of x. Let me first do here doc menu 1 I'm gonna define. Here I have f of x equals, here I have x take away 2 square x take away 5. Yeah? So I have both of these ones. So x take away 2, x take away 5. So here, the first question wants me to find the derivative. Derivative is pretty straightforward. Menu for 1, x, f of x. I'm going to turn the caps lock off on that because I accidentally turned it on. So here I get this as my derivative. So here, f dash of x just equals 3 brackets x take away 4 brackets x take away 2. Now it says here, find the values for which the derivative is less than 0. For inequalities, what the hell is happening? For inequalities, I want to use a sketch. Remember, all inequalities. This is always a rule for inequalities. You always use a sketch. Just because it makes your life easier. Because here, I can just use graph trace. And I can see, well, this is my turning point at 2. It's less than 0 at 2. So between 2 and 4, it's going to be less than 0. Yeah? So here, I would put in... okay, well, my graph just disappeared. Where the hell did it go? There's my calculator. So here, I would have x is an element from 2 to 4, not inclusive, because it is a less than, not less than or equal to. It says here, find the gradient of the line segment that joins the points of these. That is just that's just saying, that is traditional AROC. Yeah? So here, AROC stands for the average rate of change between these 2 points. So here, if I did that, I would put this in my calculator. I'm just going to check. It says f of x. So here, I'm going to do f of 5 take f of 1 divided by 4. Yeah? Which gives us 1. So here I get 1. It says here, show that the midpoint of the line segment also lies on the graph. So the midpoint of this line segment, so the first point is 1, comma, right? Let me find out what this... Why is my calculator being all finicky? So here, let's just find out what f of 1 is. I'm going to turn off that caps lock again because I turned it back on. So here, it's going to be 1, comma 4, right? That's the first point. The second point is going to be 1, comma 5, yeah? So here, it's going to be, so point 2 is 5, comma 0. The midpoint between these two, so the midpoint is just going to be 5 plus 1 divided by 2, comma 0 take 4 divided by 2. So the midpoint of these is just going to be 3 over negative 2, yeah? So here what I'm going to do is by hand, I'm going to do this by hand because it's a show that, to show that you do it by hand and you don't use the result in the show that. So here I have to do f of 3 by hand on my calculator. What I do is I go up here. So here I have 3 take away 2 squared brackets. Up here I get 3 take 5. Which is going to lead us to, so 3 take away this. So here I get 1 squared take neg 2, right? 1 times neg 2, which is neg 2. Hence, the midpoint lies on the graph. Yeah? So here, I didn't use any of the information they gave us. I just showed that by using the working out here. It says here, find the value of x for which the gradient is equal to the gradient of the line segment between these two. So the gradient of the tangent, so that means f dash of x is going to be equal to this line segment. We know the line segment is going to be 1. So here, if I go to my calculator, I can do here, menu 3, 1, I can do here 1 equals, here, fd of x, comma x, and that means I get these two solutions. So I want people to be a little bit mindful of writing plus or minus solutions. I had a lot of people on the trial exam actually mess up writing the plus or minus, because the calculator actually does some fancy shit when it spits out this plus or minus. So I want you to notice with this plus or minus, yeah, they actually make this number negative, but it actually is the same sign as it was before. They're just doing it to like mess with you. I'd be so for real. It's because the calculator likes putting square roots and stuff at the front. So here it is 9 plus or minus 2 root 3 over 3. Yeah. Here, this question, gives me a new function. I have to find a new function. So here, menu 1, 1. So here I have g of x equals what? What's g of x? G of x equals x take away 2 squared, x take away a. So x take away 2 squared, x take away a. Yeah? I have these ones. It says here, find the coordinate. So the coordinates of the stationary point of P is this and this. So we're told these two stationary points. It says find the value of P and Q. So here, we need to find the values of P and Q. We know that they're going to be the stationary point. So let me diff G of x. So here, 3, 1, 0 equals 4, 1, x, G of x, comma x. Yeah? So here, this is the positions of the two stationary points. Right? And we can, I just closed my screen here. And I can see that P is 3 over 2, right? Because what happened if if I did G dash of x equals 0, I got x equals 2, comma, 2 over 3, x a plus 1, which means that P equals 2 over 3, which means if I substitute in this point, right? If I do g of 2 over 3, so here I do this 2 over 3, I get here negative 4 over a 27. So here, if I do g of 2 a plus 1 over 3, I get here neg 4 a take away 2 cubed over 27, which means that here Q is going to be equal to neg 4 over 27. This is a very underrated technique. It is called equating coefficients. Yeah? People always forget this one. It says here, show that the gradient of the tangent of g of x will never, at the point a comma 0, will never, is positive for all values of a. So here, if we find out the derivative function, so here, x, g of x, and here we're going to evaluate it to x equals a, we see we get a over 2. So if I put in here g dash of a equals a take away 2 squared, right? Here what you can see is that if I sketch out this function, right, here I have g dash of a, and here I have a on my x-axis. It's gonna have this point at 2 comma 0 where it intersects and the tangent becomes 0, and we can see that the tangent is positive for all the other values, right? Does that make sense? So that's all you need to do, and then you can say here, hence at a comma 0, the tangent's gradient, so tangent's gradient is positive. Find the coordinate of another point where the tangent of g of x is parallel to x equals a. So here we know that this is going to be when the gradient of the tangent at x equals a. So here what I need to do, closing down. Here what I do is I do g dash of x equals a take away 2 squared. So that means x equals here, right? If I go into my calculator, I do menu 3, 1. I go this equals, here, I'm just going to do this g of x, comma x. I can see that when x is equal to negative brackets a take away 8 over 3, that's also going to be true. So here x equals negative 3 brackets a take away 8 over, wait, it's over 3, my bad. Over 3, it's also going to be true, yeah? So here what I can do is I can do g of this function, and I'll get my answer of negative 4 over a take away 2 to the power of 3 over 27. So here, this is going to be, the coordinate is going to be negative a take away 8 over 3, comma, this one is going to be negative 4, 8 to take 2 cubed over 27. And one thing that I'm actually going to do up here, I didn't define the derivative of g of x, which I'm going to just do up here. So I'm going to just say g of x equals, I'm just going to write in this derivative. Just because if your examiner is feeling really nitpicky, they'll say, oh, you didn't define what g of x is, or g dash of x is. And they'll be like, you got it wrong. You're wrong. You're incorrect. In fact, you're incredibly wrong because you didn't define the function, right? So I'm just going to put that thing up there just for safekeeping. You always want to just define g of x or g dash of x. Some mark schemes, they don't really care. Other mark schemes, they do care. But, you know. It says here, find the distance between the points, between this point and point Q. So this is the point, and this is the point Q. Yeah? Do you see how point Q and this point have the same y value? So really, right, this is what they look like. This is point Q, this is this point. It's a straight line. If I find the difference between the x values, I can find the point. So here, I know that the x value of this one has already been on my calculator. It's just up here. Here it is, right here. So this is the x value of this point, of point Q. And I'm going to take that away. I'm going to take that away from my second point, which is this one up here. And I just went all the way up. Okay, don't do that. And here I get a equals 2 is my distance. Yeah? So my distance here is a take 2. I'll come back to this probability section. I know the two of you haven't done probability, so I'll come back to it a little bit later. And we'll jump to this question over here. So here, question. So here again, doc for 1. Calculator here. I'm going to do here, find the maximum value of x for which f of x is a maximum and state the maximum value. Here, let me just define this function. So here I have menu 1 f of x equals 4 square root x take x. I'm pretty sure. Take x. Do not define it with the domain. Just be mindful that this is the domain. Yeah? So here what I'm going to do to find this maximum value, the easiest way would be to sketch it on my calculator. So here f of x, and then I'm going to just inspect it over the domain. So here, window setting, I'll go -1 to 17, and here we'll go to -1 to, let's just say, 5. Yeah? And this is what the function looks like. Yeah? So here we're going to have a turning point up here. So if I do the graph trace, I can see that the maximum occurs at this point at 4, 4. Yeah? So here, x equals 4, a maximum is at 4. At 4. Yeah? And here, to make the examiner feel a little bit better, because it's 2 marks and you need working marks, we can see that this is a stationary point, so you can literally just put over here f dash of x equals 0. So that means x equals this, and f of 4 equals 4, yeah? Now, do you see how I didn't actually do that on my calculator? I just looked at the graph. Because you don't need to do it on your calculator. That's the point, right? When you don't need to do something, don't do it, yeah? Just do the easier thing. So here, it wants me to sketch the graph. Now, I'm going to need it because it has an area calculation over here. But here, I can see that it intersects at 0, 0. And what is this other intersection point? Let me just drag it down, use my calculator. Here, it's bang on 16. So here, from 0 to 16, it has a turning point up here. So it's going to be 4, 4. This is 0, 0. This is 16, 0. The graph is going to look something like this. It's going to look something like that. Yeah. Here it says find the area enclosed by f of x in the x-axis. Well, that's just the integral from 0 to 16 f of x dx. If you're feeling really lazy and you don't really want to go. So let's try and do that on our calculator. So here, 4, 3, 0 to 16 f of x dx. I get 128 over 3. So here, keep closing down the tabs that I need. So I get that's equal to 128 over 3. Just remember to say units squared because it is an area. Here at point x, let point x be 16, 0 at a triangle at c, c, where this is a point. So we have it, a triangle is formed between these points. And here it wants us to find the value of c where this triangle has a maximum area and find that maximum area. So here, I'm gonna sketch. Okay, I'm gonna sketch on this one. I would recommend doing this during the actual exam, but the triangle is gonna look something like this. Yeah. Here it has a base of 16, a height of f of c. Yeah. So here, what we can do is we can use our triangle formula. We can do the area equals a half times by the base, which is 16, the height, which is f of c, yeah? And then what I can do here is to find the maximum, well, I can differentiate. So here, let me just go over here, do menu. So here, I'm going to write down that it's going to be a half times by 16 times by f of c. So this is c, and this is meant to be 16, right? That's that's our area function. If we differentiate this, so here differentiate it and let it equal to 0. So for 1x is equal to this, comma c. And here I need to differentiate it in terms of c, right? I can see that here c is just going to be equal to 4 when there's a maximum. And here, if I plug in 4 over here, what I'll get is 32. So the area is going to be, so 32 units squared is the maximum area. And when c equals 4, that's when that maximum is going to occur. Here it says, let a and b be two values where f of b equals f of a. Assuming that b is greater than a, show that b is equal to a. So here, right, let me, on my calculator, I'm going to just type in f of b. Here I'm going to type in f of a. Yeah. So here, it says here, let a and b be two values such that f of a is f of b. So here, we know that 4 root b equal, 4 root b take away b equals 4 root a take away a. So we know that for a fact. So here, what we can do is if b equals square root take away a. So two values in the domain are okay. B. So I've gotten stuck on this question. So am I going to sit on it for the next 52 minutes? No. Just going to skip it and come back to it. It's to show that we will use the knowledge from up here for later. Yeah. Here now it has a rectangle, so the rectangle is going to have point over here, point over here, point here, and point here. So this is what our rectangle is going to look like. It's going to have a height of f of a. It's going to have a width of f of b, right? So this is the height f of a or f of b. Here, what's in terms of a? So I'm going to do f of a. We can also see that the length is going to be, so this is a comma 0, this is b comma 0, so the length is actually just going to be b take away a. Yeah. So here what I have is f of, so the area is equal to f of a b take away a. Yeah. So here f of a b take away a, if we simplify that using my calculator, yeah. So here f of a brackets b take away a, and here I know that b is just going to be equal to, so b is just equal to, well, what we were given in that previous question, which is going to be the square root of the square root of a, take away 4 squared, which means we're going to get this expression out for our area. Yeah. So here, for simplicity's sake, I'm just going to leave it as f of a bracket. Here, this is just going to be, so I'll use square bracket and we'll have a round bracket, a take away 4 squared take away a. And I'm just going to leave it as that because that's like, that's the most straightforward. Now what I can do is with this function, I can sketch this on my CAD. So here I'm going to change it so that here a is replaced with x because I can only sketch with x on my CAS. So I do here Control C and then Control Doc, and here I want to go graph, and then we do here Control V. Yeah, I sketch this one, and I'm going to see where the maximum occurs. The maximum occurs at 0.714. Now that's not an exact value, so I'm going to go back over here. I'm going to do here menu 3, 1, 0, because I know that's a turning point. I can just use calculus. So comma x, right? It means that the turning point is going to occur at this point. So here, if we go to this other point, the area is going to be negative, right? It can't be the second point. It has to be the first point. So here, a must be equal to this value here. So here, I got my calculator, right? What I can do is I can do dA of dA equals 0. Hence, a is equal to negative 8 square root 3 take away 2 over 3. And here, I can substitute this value into here to find my value of b, yeah? So if I substitute that value in to find my value of b, so b equals, here, this is going to be a take away 2, this is squared. And now I'm going to say, given that a is equal to this first value, I get b equals 4 over 3. B equals 4 over 3. And then it says here, find the maximum area of the rectangle. The maximum area of the rectangle is going to be, well, this thing here, we're just going to substitute in this value of a, yeah? So we're just going to substitute in the value of a that we found in our question. Wait, let me just fix this real quick. So this is a at the front. Here, I'm going to put a given that symbol, and then up here, I'm going to just copy and paste this one here, because that's our area expression. So here, the area is just 128 root 3 over 9. Here, if you were to show this one, you would just have to say a, given that a equals whatever value we got up there. So negative 8 square root 3 take away 2 over 3 equals what? And then here we just say unit squared. Make sense? That's all chill. The last part of the question, it says here a trapezium, right? So trapezium is given to us where we're given here, these points, this is our trapezium. It says here, find the maximum value of A for which the trapezium has a maximum height, maximum area, and find the maximum value. So here we know the expression for the trapezium, the area of this trapezium is going to be a half, right? Here the length is going to be B take away A. We know what the value of B take away is, plus 16. So here, this length plus this length, times by the height, which is just f of A, yeah? Here we know that B is just going to be that whole square root thingy, right? So let me just get this all by itself. So here I have, here it is B take away A times by f of A over 2. And I'm going to use the given that symbol, given that, B equals this. So just given this expression, right? To find out where that's a maximum, I'll just use my derivative. So 0 equals for 1 A this comma A. We get these two values here. And just to check which one is the right one, I'm gonna sketch it on my graph. So here, if I sketch this one, so if I sketch x equals A, and then sorry, A equals X. If I sketch that on my calculator, Control C, menu 2, Control V. Wait, why is there a V? There's a V. Oh, there's a V. Here. And if I go over the different value, and it's just doing some random stuff. Here I get 0.21, which is exactly the value that I got over here. Where'd it go? There it is. Which is this value over here, which is the first one out of our two solutions. So here we get A equals -2 brackets 5 root 13 take away 19 over 9. Yeah, that's where the maximum area is going to occur. And if I substitute that whole thing into my area function, so A equals, right, this value. If I substitute this value in, I'll get our maximum area, which is 1.75. So here, our maximum area is going to be 1.75, or this whole disgusting ginormous thing, which is 52 root 13 over 27 take 140 over 27. Yeah? And then the last part of the question asks us find A of t divided by A, where A is the area of the region enclosed. So it just wants me to find the ratio between the area that I found, this top one up here, with this bottom one over here. So here, if I do this whole thing divided by what I got at the top, which was 128 over 3, I will get this ratio over here. So I'll get 13 root 13 take 25 over 288. So there's that one. Now I have 43 minutes left of this exam. Yeah. Is there any questions about this extended response so far? Let me go back and see if I can do that, show that before I move on. So this show that here. So here, I know that how can I rearrange this for B? I will what happens if I actually go on my calculator? Do either of you guys have any idea to rearrange this just for B? Because I can do. Maybe that might work. Let me check. So I'm going to make this b take away 4 root b equals a take away 4 root a, which just can become here b take away 2, wait, b root, so root b take away 2 squared, right? Take 4 a take root a take 2 squared, all squared take away 4, right? Which here, if we can rearrange this one from here, so what we get is root b take away 2 root a take away 2 squared. So I've just completed the square on both sides. Yeah. Over here, what I can do is I get root b take 2 equals root a take 2, which means that, well, b equals a, which is no use to us. So how else? So that f of a equals, this is a great question. I'll come up with a solution for this one. Like, well, when I look at it a little bit later. So interesting. Here. So B's over here, A's over here. So B's over here, A's over there. That's the distance. I do f of a equals 4 root a, take away a, which can become I'll come back to this one. This one looks like it will be a little bit harder or more worth the work than I. So it's only 1 mark, so it will be more. It will be worth more work than it's worth actually doing. So let's go up to the multiple choice and start working through that one. So here, the gradient of the perpendicular to the line that passes through these 2 points. So here, this point is going to be something over here. This point's going to be over here, right? So here, I should do -6 take 0 over 0 take 3, which is just going to give us 2. Well, we care about the perpendicular, so it's going to be a, right? Here, the period of this function is 2 pi over 1 over 4, which means it's 8 pi. So it has to be a. Here, these 2 equations have a unique solution only if here the answer is just going to be C. I've done a lot of these questions, so I have a very intuitive way to do it, but you'd have to work through all the steps here. Here, if I reflect it, so it reflected about the x-axis, so it becomes negative f of x. I translated 5 units to the right, so negative f of x take away 5. And here, this becomes negative f of x take away 5 take 6. So here, this one just becomes negative, becomes here, answer option D. This one here has an inverse function, this. So here, I'm going to open my calculator, .41. I'm going to go open the calculator screen first, and I'm just going to sketch this one. So here, this is going to be 2 divided by the square root of 3 take away x. So 2 divided by 3 take away the square root of x. So here, the domain of this one, so what is the value that this one would approach? Let's try and go to a really small x value, yeah? So it looks like it approaches 0. Let's just check the domain on this. Yeah, it goes from 3 to -3. Oh, it's +1, my bad. +1. So +1, yeah? here, if I pick, so basically what I'm doing is I know that this function should approach some number. Here I can see that it actually approaches 1, yeah? So the range of this function is just going to be 1 to infinity. So I can actually slap out answer option A and E. So I have between these three answer options here. If I rearrange this, I can either do it on my CAS or do it by hand, depends which one's faster for me, right? So here y equals x. I can see that x divided by 2, wait, x divided, take 1 divided by 2 all squared is going to be equal to 1 over 3 take away x, which means that the answer is just going to be, it has to be answer option C from rearrange. Here the asymptote, I'm just going to expand this one out. So here I'm going to open a calculator screen, so control this. Menu 3, expand. If I expand out this expression, I get 3x take away 5 over 2 take away x. So here I can see that the asymptote is going to be at -3 and 2. So -3 and 2. So x equals -3, x equals 2, so B. Here, these two will not intersect each other. This one is a very common discriminant style question, yeah? So here, it says, so x squared plus 3x is equal to kx plus 2, which means that x squared plus 3 take away kx take 2 is equal to 0. So I can actually use the discriminant here. So the discriminant of this function is going to be 3 take away k squared plus 8, right? And here, if it will not intersect or touch, right? That means the discriminant is less than 0. So here, if I sketch this function, again, this is an inequality, so I have to sketch it, yeah? This is going to be 8 take away x. I know, is it 8 or is it 3? It's 3. So it's 3 take away x squared take away 8. If I sketch this on my function, I can see that it's going to be between these 2 points. So I have to find the x-axis intercepts of this graph. So if I go here, menu 3, I do 0 equals the x-axis intercepts, which is going to be 3 take away k, 3 take away k squared plus 8, comma, k. Is it plus or is it a minus? What did I write here? I put a minus here. Is it meant to be a minus? So here, b squared minus 4ac. But I'll come back to this one. But here, let me just see. Take away 2. Oh, because it's already it's negative over here. That's why. So it's actually negative, which makes this positive, which makes this one here negative. Right, so this is actually a negative over here. So here, if I go back to my calculator screen, I replace this for a negative. I get here these two values, and I know I need it to be between these two values. So answer option is going to be, it can't be D, it has to be A. The reason it can't be D is that's when it will equal 0. When it equals 0, it will touch the x-axis intercept because the discriminant will be 0. Here it says find the average value between these 2 points. Yeah, I can see intuitively that this area, these two areas are the same. And because integrals count those areas, so here I'm looking for the integral from -a to a, yeah? Integrals count these areas, they'll cancel each other out. So these two areas cancel each other out. Now I'm left with this, yeah? I'm left with this whole rectangular box, which is just going to be a squared. So here I have 1 divided by a take away a all over a squared, right? Which is just going to leave me with 1 take away negative a, which is going to leave me with 2a over a squared, which is just going to be a over 2, which means the answer option is going to just be D here. So that's the average value. See, they didn't give me anything. They didn't give me a function. I just have to figure it out using my understanding of that formula. So here it says the range of this function between these 2 points. So I want to remember that the domain has been changed. So let's have a look at this function here. So control 2. Here, let me type in ln of x squared, ln of x squared, and let's try and limit its domain. Let's limit its domain to negative 1 over 2, negative 1 over 2 to x, negative 1 over 2, all the way to 2. Yeah, so you get negative 1 over 2 to 2. Here, right, this is going to be the highest point over here. We can see that at 2, it's going to be the highest point it can be. Yeah. And it's actually going to go all the way down to negative infinity. That's what we're seeing here. So here, let me see what ln of 2 squared actually is. So ln of 2 squared, that's just 2 ln of 2, which means the answer is just going to be answer option C here. What a lot of people accidentally do is that they'll just pick the 2 endpoints and say, that's it. No, you can't do that for ranges. You have to sketch it out. Here, the tangent, which is parallel to this line, so we want a tangent to be parallel to this line, and it wants me to give out a general solution here. So here, that means I need to say that the derivative of this function, so here, what's this function? It's going to be x 3 sine of 2x take away 1 is equal to the gradient of our line, which is 3 comma x. So here it becomes this. So if we look at our answer option, so here x equals 6n take, it's actually plus or minus 1 pi over 6, which if we rewrite this out is actually just going to become n plus or minus pi over, so n pi plus or minus pi over 6, which is just answer option A here. Here, a bag contains 5. The reason why we're looking at all solutions is because they haven't restricted the domain of sign, so we have to assume it's a maximal domain. Here, a bag contains 5 marbles and 4 red marbles. 4 marbles are chosen and taken out of the bag without replacement. The probability that the proportion of marbles in the sample is greater than 2. So here, this is telling us we want the proportion p hat to be greater than a half. Yeah? This means if we convert it to its x value, we just times it by the number of marbles we took. So it has to be greater than 2, which means that we want to pull out 3 blue marbles, plus we also want to pull out 4 blue marbles. Yeah. Here we're going to use our technique, the hypergeometric. Yeah. So if we use our hypergeometric over here, let me just write out the calculation over here. So menu 3. This will be 5, 3 times 5. 3, which is 4 1 over 5 3 9 comma 4 plus this one here is, so I'm just writing this all stuff. I'm just writing this all down on the calculator because I have a lot to write down. So here 5 3, this is 4.0. 5 3. So here, oh wait, that doesn't add because I did it with the first one. Okay, that makes a lot more sense. So here, ignore these top 2. I've written these 2 wrong. So here, out of 5 blue marbles, I'm picking 3 of them. Out of 4 red marbles, I'm picking 1, and there's a total of 9 marbles with 4 being chosen. Yeah, I'm doing the same thing over here. So this is the probability that x equals 3. This is the probability that x equals 4. That if I do this addition, I'll get 5 over 14. So here, 5 over 14, answer option C. Question D. Here, the temperature is normally distributed with a mean of 95 and a standard deviation of 2. When the kettle is used, the proportion which reaches a maximum temperature greater than 98. We want it to be greater than 98. So if we look at our normal distribution, here we have our mean of 95, our standard deviation of 2. We want it to be greater than 98. So here we go, menu 552. Here we want our lower bound to be 98, our upper bound here to be infinity, right? Our mean to be 95 and our standard deviation to be 2. We get 0.666, which is answer option B. Yep. Here it says the mean and the variance of the distributions are. So here, because it wants me to find the variance, I'm going to write x squareds up here. So this is 1, 0, 1, and 4, right? Here, the mean of this one is just going to be negative a plus 2a plus 2b, right? Which is just going to simplify to 2b plus a. So answer option C, D, and E are out. It's between A and B now, yeah? Here, I would have, so E of x squared, because I know for the variance formula, I need E of x squared, take square root, take brackets, E of x, all of this squared. E of x squared is just going to be 4b plus 2a plus a, which is just going to be 4b plus 3a, yeah? So then what I do is I'm going to go to my calculator, and I'm going to go here, this is going to be 4b plus 3a, take away, this is going to be 2b plus a all squared. So here it looks something like this. If we look at the calculator, right, that's actually going to be answer option B over here. So it's really big and complicated, right? But if you actually expand this out, so if I do menu 3, I actually expand this one out, I can see it's exactly the same as what we've been given here. So here, the function with the graph shown above would be, yeah? So here we want to notice that the period of the function is 2a, right? So here this is 2 pi over n is equal to 2a, which means that a is just going to be equal to, n is just going to be equal to pi over a, yeah? That's what we get. So it should be pi over a. So we take out any answer that has an n that isn't pi over a, yeah? So now we're just left with b, c, and d. Here we're told that the maximum is a and the minimum is 0. So here, that means the median line must be at y equals a. So we take out any answer option. So we know that the amplitude must be a. So that means b is out. So here between c and d, yeah? Here, E is the most obvious answer option I would pick because it starts off at a minimum and it goes up and it follows the pattern, yeah? This one, D, is a little bit more complicated, right? Because of this translation by A units, yeah? So here, if we think of a sine function, if I think of the sine function, the sine function will look something like, this. If I translate this A units forward, I will actually start off here and then go down, yeah? Which is not what we want, yeah? So it has to be answer option E. Here, okay, this one is the one we spoke about before. Do you see how they have exactly one intersection? It means that f of x must be equal to x because it passes through this line, y equals x. But because y equals x is a tangent, f dash of x must also be equal to 1. So here we get e to the kx, we get k e to the kx, right? I know that 1 over k equals e to the kx, which means that x equals 1 over k, yeah? So if x equals 1 over k, I can actually substitute that back into this equation up here. I get 1 over k equals e, which means k must be equal to 1 over e. You can also solve that simultaneously using your calculator. I've just chosen to do it by hand because I have a nice trick to do it by hand. Here, the bounded area between this and this, So between 1 and 4 is 8 units. Here, what's the bounded area between these two, right? So here the bounded area of this function is going to be, so I've integrated 2f of x, take away 1, from 1 to 4 dx. That's just going to be the same as 2 from 1 to 4 f of x dx. Take the integral of 1 to 4 f of 1 dx. This is just going to be 16, take away 3, which is just 13. Yeah? Because the integral of 1 to 4 of 1 dx is just going to be 3. Here, which one of these satisfies this relationship? The only one that satisfies that relationship there is going to be... here, you'd have to... Question. It's not answer option B, because if I add two linear factors together, that won't get me to where I want. Here, it's answer option C here. Now, why have I chosen answer option C? It's because I have to somehow get an x squared from an addition. By log laws, I can an addition is the same thing as multiplication in log laws. That's why I looked at answer option C. Yeah. Here, we're given this x to the power of m, e to the power of ax, where a and m are this. If x plus 2 is a factor, which of the following must be true? So here, factor implies that x equals -2 is a solution to f dash of x equals 0. So what we can do is go into the calculator. We can do menu 3, 1, 0. Oh, wait, no. Let's first do the derivative. So for x, x to the power of m times it by e to the power of e to the power of a times x. And here we know that x is equal to -2. Yeah? So we know that x is equal to -2 here. Right? We know that this whole thing must be equal to 0. So comma m. We see that m equals m equals 2a, right? I don't know why it's writing ln of e, right? Because the thing is, ln of e is just 1. So, no shit. I don't know why the calculate. Maybe, it might be, because I didn't use special letter e before. Let me replace this with special letter e, and I'll show you why the calculator's done that. Yeah. So here, I've used special letter e, and if I let this one equal 0 and solve for m, I see that m has to be equal to 2a. So that's what I get as a solution there. Here for this one, I want you to notice this is called a probability mass function. Yeah, we don't deal with it that much in methods, but it's a nice thing to know. Essentially, this relationship is the probability at any of these points between 1 and 9. So here it wants me to find the probability that d is greater than 8, given that d is greater than 7, which is equal to the probability that d is actually equal to 9 divided by the probability d equals 8 plus the probability d equals 9. Yeah? And here I use this mass probability. I use this mass probability function. So here I have 1 1 f of let's not call it f. Let me actually just define here the log. So here, control this log. If I don't put a base there, the calculator implies that it's log base 10. So it's 1 plus 1 over d. So I get here this. So here, if I do this whole thing divided by Control C. I'll make this one Control. So Control B plus Control V. This is going to be 9 here. This one's going to be 8. And this one here is going to be 9. So this is the probability that D equals 9. This is the probability that D equals 8. This is the probability that D equals 9. Yeah? If I divide those things all together, I'll be just left with, here, this is going to be, which one of these answer options best fits it? Which one of these answer options? So, if I go into this one, I'm not sure about. Main reason being is because the calculator is given it in a bit of a weird form because I've used log base 10. What would it be here? Because my guess, I want to try out all the answer options. I'll come back to this one, yeah. And then here we have this one where it says here the maximum set of values of A for which f inverse of x exists is the following. So these are the maximum. This is the maximum set. So we want to find the values of A. Basically, we want this function to be 1 to 1. Yeah, that's what we want it to be. We want it to be 1 to 1 for an inverse function to exist. Yeah. So this actually means we want it to be 1 to 1 over this domain. Yeah. So what I'm actually going to do is I'm going to go to my calculator. Yeah. So calculator, and here I'm going to real quick put this whole function in. So let me just check this whole function. This function is going to be x to the power of 4 plus 2 times a take away 4 times by x to the power of 2 take a x plus 1. So I'll create a slider for a. And here we can see this function is not 1 to 1. Now, the question's actually given us guidelines of what numbers we can actually select. So let's start off with neg 9. Yeah? If it's neg 9, let's just say we go less than neg 9, so we go neg 10. No, that function is not 1 to 1. Yeah? So let's say we instead choose here the other option that the calculator has given us is between neg 9 and 10. So here, let's just say neg 8. No, that's not true. It's not 1 to 1. Yeah? It's not 1 to 1 when x is greater than 2. That doesn't work. So let's try at it when it's greater than 1. So here, this is when it's greater than 1. So here, this function isn't 1 to 1 when x is greater than 1. So let's go all the way to 8. Yeah? 8. Oh wait, this is negative 8. Okay. So none of those have yielded me anything. Yeah? So how I'm going to go about doing this one is I want to make sure that x is greater than 2. Is that correct? Yep, so x is greater than 2. So here, this is what this function looks like when x is greater than 2, and here we have 1. Yeah? So 1 actually does look like it works. Yeah? So let's use our slider. Let's go backwards. Yeah? If we go backwards, if we push it forwards, right, nothing happens. You know, let's go all the way to our neg 8. Yeah? Neg 8, it becomes not 1 to 1. But let's go to neg 7. It's still not 1 to 1. So here, it's probably something, or it's probably something over here, down here, that's messing with us. So let's go over to calculator, graph to here. We'll have it go to -1. This one will go all the way down to, let's just say, yeah. So here, we make it like 5. We make it like 6, or like, let's make it like -1. -1 almost looks like it works, but it's not quite 1-to-1. So let's go straight to 1. 1 doesn't actually work either, so let's make it 2, yeah? And 2 almost works, but not quite, yeah? So let's go to 3. That's 4. So 4, 3. So 3 doesn't work, but 4 is starting to look like it works. And here, 5 definitely works. So 5 definitely works. So here, none of our answer options actually match with that. So let's go less than -8. So let's go less than -8 and see if that yields us any useful results. So less than -8. So -8 doesn't quite work, right? What about -9? Okay, this question is also stumped me as well. So the maximum set of values of a for which the inverse function exists. We want the function to be 1-to-1. Okay. So it looks like we got stumped on 3 of the multi-choice questions. Actually, yeah. No, 2 of the multi-choice questions, yeah, and 1 of the extended response questions. But overall, it's not too terrible with the timing that I had, yeah? So do you guys have any questions? I'm gonna stop the recording here. Do you guys have any